Okay, problem number 3. Consider this Venn diagram below, and let's find the number of elements in A complement intersect B intersect C. So let's write this here. The number of elements in A complement intersect B intersect C. So the first, I'll show this 2 different ways. The first approach will be a more intuitive approach. We want the intersection of these 3 sets. So in effect, we really want the number of elements that are not in A, in B, and in C. So not in A, I can't have anything in A. The intersection, so I want what they have in common, what these 3 sets have in common. In A here, I don't want any elements that are in A. Nothing in A. But I want the stuff that's in B and C at the same time. So nothing in A, but in B and C. So if I think about what B and C is, B intersects C. Here's B intersects C. This is what B and C has in common. Right here. Right here. 6 and 2. But I don't want any elements that are in A. Not A. So instead of B intersects C, instead of these 8 elements, I only want these 2 elements here. So I want the stuff that's in B and C, but not in A. So that's just 2 elements. That's the intuitive approach. I'm sure some of you get it that way, and some of you think of it in that way. And I know others need a more concrete kind of approach to solving this kind of problem. So here's a more concrete, I think, way of thinking about it. So let's label each of these regions, just like the book does. 1, 2, 3, 4, 5, 6, 7, 8 regions here when we have three circles in a Venn diagram. And each of these regions has a corresponding number of elements. Region 6 has 18, region 5 has 1, region 1 has 10, etc., etc. So we want to know the number of elements in the set A complement intersect B intersect C. I want the intersection of those 3 sets. I want to know what they have in common. So let's write this out. A complement. Let's write out all the elements in A complement. All the elements that are not in A. I say elements, I mean regions. All of the regions that are not in A. The regions. So the regions that are in A, 2, 3, 4, 5. That's here. The regions that are not in A, 1, 6, 7, 8. Those are my regions that are not in A. 1, 6, 7, 8. I want the intersection of that also with B. Everything that's in B, all the regions that are in set B. 3, 4, 7, 8. It's the regions in B. And the regions in C, set C. Here's the C circle. 4, 5, 6, 7. Those are the regions that are in set C. Now, this is it right here. I want the intersection of these 3 sets. I want to know what these 3 sets have in common. Intersection, what they have in common. Only tell me that. The regions that these 3 sets have in common are, it looks like just 7. See, 7 repeats in all 3. 7 is the region. This is the region. I wrote that really poorly. Let's rewrite that. The region. So 7 is the region. This number, small 7, the red 7 here, is the region where all 3 of these sets intersect. So the number of elements in that region, that single region, number of elements in region 7 is 2. That's our answer. Just like up here. 2.